Hi and welcome. In this video, I'm going to describe how to control a servo motor using Atmega16 microcontroller and programming in MikroC Pro for AVR compiler. So let's first discuss the simulation model in Proteus ISIS. I'm using the Proteus 7.10. So this is the 16x2 LCD connected to port C of the Atmega16. This is the servo motor connected to port B pin number 3. You need to set or you need to configure these parameters for the servo motor: the minimum angle 0 degree, the maximum angle plus 180 degrees, rotation speed can be 10 to 60, minimum control pulse 1 milliseconds and maximum control pulse 2 milliseconds. This simulation model is a virtual terminal for serial communication. So you can get this terminal from virtual instruments mode and select virtual terminal. The RxD of this virtual terminal is connected to the TXD of Atmega, and the RxD of Atmega is connected to TXD of virtual terminal. You need to configure the parameters for this virtual terminal if you are getting different parameters. So the baud rate is 9600 and others are by default set to these values. So the idea behind this project is to send the angle value through the serial virtual terminal, and the Atmega will convert that angle into duty cycle for servo motor and set that angle on the servo. The same angle value will be displayed on the LCD. So if I set 190, then hash, this is the format how I am sending the angle value through the serial terminal. So it's an invalid angle value because the angle will be valid if it is greater than or equal to 0 and less than or equal to 180 degrees. So if I am sending 180, then hash, the servo angle is set to 180 degree as well as it is updated on the LCD. If I'm setting the angle to any other value, just like say 1 degree, so servo is setting to approximately to 1 degree and LCD is also displaying that updated angle value. So let's see how the backend means the program is working and how you can modify the program as per your requirements. To control the servo motor, you need a 50 Hz PWM signal with only the duty cycle variation from 5% to 12%. It will be different for different kind of servo motors. So the duty cycle is the portion of pulse high during the 50 Hz frequency. So if the frequency is 50 Hz, the pulse duration will be 20 milliseconds and the signal will be high only for 1 millisecond to 2 milliseconds, and it will remain low for the entire duration of the pulse. So we need the pulse high only for 1 millisecond to 2 milliseconds in most of the cases. Otherwise, you can see the datasheet of a particular servo motor for the duty cycle percentage or the timings. So first of all, these are the declarations of the pins of port where the LCD is connected. You will need to refer to the library manager for the MikroC compiler and need to include these libraries: the conversions, C stdlib, cstring, ctype, LCD, LCD constants, sprintf, and uart. Make sure before doing any of the coding referring to this tutorial, you have selected these libraries. I am not going to use the hardware PWM library from the compiler because I will generate the PWM by the software. Okay, let's back to the code. This is the declaration of pins used for LCD. The pin for servo motor, which is port B pin number 3, as well as the direction set to the DDR register B3. I am declaring here two different arrays. One will store the values received from the serial terminal and another will have a converted angle value from string. So this array will store the string to integer conversion. I have a flag variable declared here to just mark that if the serial data is received or not. Then I have the delay high and delay low variables, because delay high will denote the high duration of the pulse and delay low will denote the low duration of the pulse between the 50 Hz or 20 milliseconds time period. You will be familiar with the map function, mostly used to convert one range to another range. This is a similar map function used in most of the Arduino projects when there is a need to convert a variable's value from minimum to maximum. So this function is required to convert the received angle value into the percentage of the duty cycle required. Next, I have a function to update the LCD. So what it is doing, it is just clearing the LCD. So at very first it is clearing the LCD so that we can neglect any garbage data if it is displayed on the LCD. Next function is a sprintf function, which is included from the library sprintf, so that library is required. This function will convert the angle or whatever the string response received over the serial terminal to the integer. So this is the conversion. Then these two lines are printing the servo angle set to this value. So I am printing this on the very first row, starting from very first column, and this will be printed on the second row and first column. As I said, I am going to generate a software PWM. So this is the function which will provide a high pulse delay and low pulse delay. The next is the main function, and here are some initial setup lines of the code. The servo direction is set to 1, so this instruction is making the servo pin as an output pin. This flag will indicate if the serial data is received or not. That's why it's set to 0, means no data has been received. The LCD is initialized. This is from the LCD library. UART is initialized with 9600 baud rate. These two initial commands will set the cursor to the very first location on the LCD, and LCD will be cleared. Then I'm calling this function to update the very initial value of the angle, which will be 0 degrees. So I'm calling this function here. This while one is actually an infinite loop and carrying all those instructions required to receive the serial data, then conversion of that serial data into an angle and printing on the LCD, and as well as setting the angle on the servo. So this first if statement is carrying the UART read text function. This function will return a value greater than 0 whenever there is a data to read from the serial port. So if there is a data available, we will read that data by using this function read text. This function will store the data in an array, and first argument is a buffer which is required to store the read response. The second argument is the delimiter. The data will be read up to this delimiter. No matter if you are sending only 1 byte, if you are sending 3 bytes, you should terminate the data with hash. So your expected response will be the angle value terminated by hash. So it is checking the correct response included hash within the 4 bytes of the received data. Then the flag is set to 1, which is indicating that the serial data has been received. So it is moving to the next if statement. So if the data is received, I'm converting the received response, UART response, which is a string value of the angle. This is the function a to I, which will convert the string into integer. So if the converted integer value is greater than equal to 0 and less than equal to 180, then it will go through all these statements. Otherwise, it will just print invalid angle. for the servo. And at the last, we need to clear this serial data received flag to 0, otherwise it will not work properly, and this should be 1 again whenever there will be the data available. So you will compile or build the project, and you will set the clock frequency to 16 MHz, and you will select the generated hex file, and you can run the simulation now. If you are not getting this virtual terminal, you can go to debug and you can select the virtual terminal. So the data sending format is the value of angle, then terminated with hash. So it is setting that value on the servo. 0 hash, returning back to 0. 45 hash, going to almost 45. 90 hash, going to almost 90. So this is a little bit hard to set up the servo control in simulation because the timings are very difficult to set in the program. I also have created a Git repository for Atmega16 and MikroC projects. I will share the link in description. Thanks for watching.